Welcome to clickmyproject.com. The project title is Image Scrambling using R prime shuffle on image and image blocks. The project abstract is we propose a security of digital images is also of high concern. In this paper we have to extend the R prime shuffle technique over the blocks of image. The method is applied to different block size in the image and also compared to the earlier R prime shuffle technique of image scrambling. Finally we got on original image. The project flow diagram is to apply the shuffling process and get back the original image. When we read our input image, we have to encode the another image to our original image. So the first image will be height and second image will be to show on our interference. Next we achieve the scrambling method. In scrambling method we are using the R prime shuffling. In R prime means it mention on a row of our input image. Next we have to decode the image. In R prime only to take the row of image value to scramble. When we decode the image, only the row value to decode and show the original image. The project source code was run from the command window. So current folder shows the our main file.m. So we have to run the main file.m. So the process will be going on. The process will be completed. So initially we are taking the figure 1 is so when we are transmitting the antenna from transmitter to receiver, so the bulk transmission is maximum and bulk transmission is minimum, and pre-subcarrier for maximum and pre-subcarrier for minimum. Then TDMA constrained per subcarrier maximum and constrained per subcarrier maximum value will be shown. Then no selection on the will be shown. So in X label shows the number of secondary users and Y label shows the total capacity. So it is the initial of our transmission antenna. So in figure 2 shows the after transmitting the antenna, the values will be shown on table. So if you want means you can verify the value to our transmitting antenna. So in figure 3 shows the SNR to calculate the our transmission antennas. So according to the color band, so the transmission will be going. So in blue color line shows the no selection and red color line shows the bulk maximum and minimum and per subcarrier maximum and minimum value, then TDMA with antenna selection. In X label shows the number of served user and Y label shows the ergodic secrecy rates. So according to the graph, the value will be shown on the table. In figure 5 shows that the CDF response for bulk transmission antenna and no selection, and TDMA with antenna selection and TDMA. So it is the value to show the table. In figure 7 shows the capacity level to compare our CDF. So it is based on our no selection and bulk maximum minimum and pre subcarrier maximum and minimum values. In figure 8 shows that the capacity level for performance of our antenna selection. So it is the value to show our pre-subcarrier values. In figure 9 shows the BER versus SNR for a reconfigurable multi-antenna system. So in bulk maximum will be shown on our blue color line, black color line, and the bulk minimum will be shown on the black color line. So it is to vary some different black color lines. So in X label shows the SNR and Y label shows the bit error rate. It is the BER value to calculate in table. So it is the BER values. In figure 11 shows the our receiver antenna selection for APSS. So it is RS-BES to compare our channel capacity level and CDF. This is a value to shown on the graph. In figure 13 shows the high SNR regime for our antenna selection. So it is the maximum and minimum value of bulk, no selection, and TDMA with an antenna selection. And finally the value will be shown on the table. So according to that process, the variable values are shown in the workspace. So if you want check means, so we can verify that value for minimum and maximum value, so in the workspace. So the project demo was completed. Thanks for watching this video.